Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Long gap, right? Hey Avenger, thank you so much for asking for this video. You got me out of my sleep. In our previous videos, we've done compounds like sodium chloride and how do we name such simple compounds by crisscross method. And if you realize all of these are ionic compounds. Those of you who are new to learning chemistry, don't worry. We will be talking about ionic and covalent compounds later on during the course of your learning journey. But for now, Avenger actually asked me to record a video to name compounds like sulfur dioxide, carbon dioxide, and so on. So let's get started with that today. When we name some common compounds, there are certain things that you will need to commit to memory. Mono very clearly means one. The word di or bi stands for two. So these are prefixes that we will attach to the name. Pre means one which comes before. So we will attach this prefix to let us know how many of the atoms of each type are there. So if you see tri is 3, simple, right? Triangle, remember in your mathematics you do triangle, 3 angles, right? Tetra is for 4. Penta is for 5. Hexa is for 6. Remember again connecting to what you do in mathematics. Hexagon, pentagon and so on. So just learn these first. So mono stands for 1. Di or bi stands for 2. Tri for 3. Tetra for 4. Penta for 5. Hexa for 6. Okay, close your eyes. I'll ask you randomly. Tetra. 4. Di. 2. Good. Mono. 1. Hexa. 6. Wonderful. So let's go on to the next. So when I say a compound is carbon monoxide, so this is carbon. Monoxide means there's only one oxygen attached to it. Be careful, there's a capital C and there's a capital O. Now you must be wondering, why am I not doing the crisscross method? As I explained earlier, crisscross method is most of the time applicable when you have a metal combining with a non-metal, okay? Whereas the compounds that we are talking about here are all gaseous and these are non-metal combined with a non-metal. So the type of bonding that has gone on into them is what we call as covalent bonding. Carbon dioxide. So see the di, that means how many of oxygen? CO2. Yes, you use it every day, right? You use the name as well as the formula. You talk about it in biology and chemistry quite a lot. So what about sulfur dioxide? So 1 of sulfur and 2 of oxygen. Actually, if you ask me, technically, it should be monosulfur dioxide. That means 1 of sulfur and 2 of oxygen. So try naming sulfur trioxide and diphosphorus pentoxide. Try it. Pause the video. Write the formula. This channel is all about pen and paper. Right? So I would want you to keep writing down the notes, whatever you see on your screen. I'm waiting for you to write. Go ahead. Sulfur trioxide written. Okay, let's go ahead and give you the answers then. You want to check. Sulfur trioxide. SO, tri is 3. Diphosphorus. Pentoxide, that means 2 of phosphorus and 5 of oxygen. Right now, tell me, could you get these right so far? Okay. That's the next one. Dihydrogen monoxide. What compound would this be? Yes, this is our favorite water, right? Now, if you realize, some of these compounds are popularly known by their common names. For example, water, right? We will take more examples like this a little later on in the video. Okay, do you remember the compound hydrogen peroxide? What is the formula for hydrogen peroxide? Do you remember the symbol, the valency? H2O2. Now realize over here, the oxygen that we are writing O has to be a capital alphabet. The H that we are writing will be a capital H. Also, although it looks like a change in a small number, but it changes the nature of the compound completely. That is why we need to understand what we call as the language of chemistry in order to gel with it and in order to make good friends with it so that we can learn it smiling. Other examples of compounds commonly known. So when you say hydrogen in the common terms, it's actually more technically speaking, it's dihydrogen. So in most of the recent books, you will find it written as dihydrogen and not just as hydrogen alone. In your earlier publications, you would find it written as just hydrogen. But IUPAC recommends that we call it as dihydrogen instead of hydrogen alone. So if I am saying hydrogen gas, that means I am talking about H2. So can you try naming the other compounds? Dioxygen, dinitrogen, dichlorine? Yes, what you call otherwise as chlorine gas, right? Or chlorine molecule. Once you've written the answers, you can proceed to check them. I'm waiting for you to write them complete. So you can try fluorine, bromine, iodine as well. If you know the symbols, yes, F, remember, from the first alphabet. BR from the first two alphabets. I from the first alphabet. For chlorine, we don't say chlorine, right? So the H is silent. So C and an L, remember? So what do we have over here? O and a 2, N and a 2, Cl2, F2, Br2, I2. Now try naming these. Ozone. Try oxygen. So how many of oxygen? Nitrogen dioxide. Dinitrogen pentoxide. Dinitrogen monoxide. Go ahead. Written. O3. Nitrogen dioxide. Dinitrogen pentoxide. Dinitrogen monoxide. Yes, you see in a lot of your earlier publications, even in your the curriculum books, you will find the name written as nitrous oxide, because the IUPAC system has evolved over time. That is why some of the compounds you will find more popularly known by their earlier names, by their common names like nitrous oxide. We are trying to streamline it now by giving proper name for the prefixes and the suffixes. So that's why nitrous oxide. Yes, you're laughing. Yes. Right? I hope if chemistry becomes easy for you, you'll also start smiling and laughing. Now, as I mentioned to you, there are certain compounds which are more popularly known by their common names. So when I say hydrochloric acid, HCl, it's basically hydrogen chloride solution. That means hydrogen chloride gas dissolved in water. That's why hydrochloric acid. But remember, the L has to be small. So it's a capital H, a capital C, and a small L. Sulfuric acid is nothing but hydrogen sulfate, but you will everywhere find it written as sulfuric acid, H2SO4. Nitric acid, HNO3. Now, these are some of the formula that you will have to commit to memory so that you can recall and use them easily while studying more topics in chemistry. Okay? Phosphoric acid, H3PO4. Why don't you make a separate notebook for chemistry and whatever topics we are doing on the channel? You will have your notes ready by the time you finish watching these videos, provided you are writing down whatever I'm saying. Acetic acid. Now this I'm going to just add to your memory. CH3COOH. Oh, this looks weird, right? Don't worry. You will study about it a little later during your learning journey. But for now, make sure that you have learned these formula. So once again, close your eyes, try answering the questions I'm going to put to you. Be honest, don't open your eyes till you've answered. Nitric acid, acetic acid. Yes, acetic acid is CH3COOH. Don't worry if you didn't get it right in the first place. Hydrochloric acid, HCl. Sulfuric acid, H2SO4. Carbon dioxide, carbon monoxide. Sulfur dioxide. Hello, Avenger. Are you comfortable now with the formula? If you are, please don't forget to share the channel with your friends and classmates, and definitely don't forget to let me know how you are doing in your learning journey. See you in the next video very soon.